G'day again. Welcome back to Mathematics 302. Hope you're having a good morning or a good evening, as the case may be. Hope you're having maybe a nice breakfast. I don't know, some nice fruit or something, maybe a nice coffee, or maybe having dinner. Anyway, God bless you. I pray everything is going well for you. And if you're facing a challenge, I pray God grants you strength. Okay, we're in Lecture 8, and this is Lecture 8, Part D. So we're going to go through norm and ball relationship, norm vectors, norm matrices, and there's some examples after that. Okay, so let's get into it. Okay, so a norm and ball's relationship. A norm defines a distance of a point from the origin, and the corresponding ball is a set of all points that have a distance less than or equal to a given radius. I haven't got any examples of a question on that at this stage, but I will be creating some later, as in, just handwritten ones. A norm vector, so these ones on the other hand, there'll be lots of different questions. So a norms can be applied to vectors. So for example, the easiest way to do vectors and matrices is to give you the examples. So a norm of the vector 3, 4, which you would have done for sure. In two dimensions, this is simply using Pythagoras. So the norm is the length of the vector. So you've got 3, 4, and you know already what the answer is because you're clever and you're in third year mathematics. So 3 squared plus 4 squared is 25. The square root of 25 is 5. There we go. Straightforward. We've got to determine the norm of the vector 3, 4, 5. You might not be able to do that in your head, but it's the same principle. So it's the square root of the sum of the squares of the component vectors. So 3 squared plus 4 squared plus 5 squared, add that together and we get 50, square root of 50, and you can simplify that as 5 root 2. For matrices, there's 4 types of norms for a matrix. You may or may not have heard of these. If you haven't studied it, you won't have. If you have, you might have done one of them, but unlikely would have done all 4. So the norm, when you just say, what is the norm of a matrix, is the maximum of the sum of the absolute values of the columns. The spectral norm is the square root of the largest eigenvector value of A transform. That should be A transform A there, actually. So there should be another A there. Infinity norm, but you'll see that in the example when I do one. Infinity norm, maximum of the sum of the absolute values of the rows. And the Frobenius norm is the square root of the sum of the squares of all the elements in the matrix. So this Frobenius norm is most likely the one that you might have seen because it's basically identical to a vector norm. Okay, the others you may or may not have seen. So, but that here up here should have A transform A, but you'll see that when we do an example. So for the two-dimensional matrix, so we've got 1, -1, 2, and 4. The norm for the columns, norm 1 norm is 5. The 2 norm, the spectral norm, is 4.497. The 3 norm, called the infinity norm, is 6. And the Frobenius norm, or 4 norm, is 4.69. So these numbers are just common or commonly used when they refer to the norms. When you're given it as a question, I'll make it clear that you're looking for, the column norm, the spectral norm, the infinity norm, which is the rows, or the Frobenius norm. Okay, so I'll make it as clear as possible so you know which one you're looking for. Okay, there's also a calculator. There's a bunch of different ones. If you Google matrix norms or calculator, you can come up with a bunch of them. I'm using the Omni calculator just to check my work, and that's how you can do it too. It's pretty straightforward. The trick is to do it without the calculator. So let's go. So determine the 1 norms or the columns. So column 1, the absolute value of the first number is 1. The absolute value of the second number is 2. So 1 plus 2 is 3. Column 2, the absolute value of that is 1. The absolute value of that is 4. So 1 plus 4 is 5. So we want the maximum of these for the columns. If there are lots and lots of columns, you go through all of the columns and you find the maximum. So the maximum total in this instance is 5. And that's the 1 norm. That's the answer. So it's very straightforward to do. You just got to remember, okay, I'm doing columns. If I'm doing the one norm, I'm doing columns. For the two-dimensional matrix, we use the same matrix, find the spectral norm. So this is the maximum lambda of A transform A. There's that A. Okay, the maximum lambda of A transform A. And probably should have another bracket in there. Doesn't really matter because it's all in square root. Okay, so the lambda here, when I talk about lambda, or when anyone talks about lambda, it's the eigenvalue. So what we'll do is we'll figure out A transform A first. So there's A, there's A transform, there's A. We've just swapped that column is now that row. Sorry, that row is now that column, and that row is now that column. So then we've got A transform multiplied by A, and we're just going to go across and down, across and down, across, down, across, down. So when we do that, 1 plus 4 is 5, minus 1 plus 8 is 7, minus 1 plus 8 is 7 again, and 1 plus 16 is 17. So that's pretty straightforward calculation to get A transform A. So now we want to do the eigenvalue. We want to find the maximum eigenvalue. So you do that by going, what is the determinant of A minus lambda I, where this is the identity matrix. So A minus lambda I, and we put the determinant equal to 0. So this is, we're calling this A minus lambda I is just minus lambda on the diagonals. And now we're going to find the determinant. So these, we're going to multiply 5 minus lambda multiplied by 17 minus lambda, and we're going to subtract 7 times 7. Okay, that's finding the determinant. So we do that calculation and we get 85 minus 22 lambda, so 5 plus 17 is 22, plus lambda squared, minus times a minus is a plus, and then we've got minus 49. So now we're going to do 85 minus 49, put the lambda at the front, and we've got a typical quadratic equation. So lambda squared minus 22 lambda plus 36 equals 0. Solve that, find our two lambdas. So because if you hear your 36, closest you could get possibly will be 18 and 2 as your factors. That doesn't add up to 22, and then you're going to go smaller. So 4 9s isn't going to cut it, 12 3s isn't going to cut to get us to 22. So we're going to have to use the quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. You should know that one off by heart because hopefully you're teaching it to your students to learn them off by heart, although they've probably got formula sheets, which is a bit lazy, but that's the way life is at the moment in mathematics. So lambda is 22 plus 18.439 over 2, or 22 minus 18.439 over 2, and that will give us lambdas of 20.22 or 1.78. We want the maximum lambda, so that is 20.22. That is the biggest one. So the largest eigenvalue is 20.22. And the spectral norm is therefore the square root of 20.22, which is 4.497, sorry. So 4.497. Okay, so that's how you do the spectral norm. It is pretty straightforward as long as you do just A transform A, find the determinant, which, find the determinant, or you're finding the eigenvalues just here and here, and then you're just taking the largest one and taking the square root. So that's it. That's the hardest one. The other ones, the other three of these are straightforward. For the two-dimensional matrix, determine the 3 norm, which is the infinity norm. So instead of doing columns, we're doing rows. So absolute 1 plus absolute minus 1 is 2. And then row 2, absolute 2 plus absolute 4 is 6. Which one's the biggest? The maximum is 6. So the 3 norm, or the infinity norm, is 6. That's it. Very straightforward for 1 and 3. For the 4 norm, the Frobenius norm, we're just going to square everything. So 1 squared plus minus 1 squared plus 2 squared plus 4 squared, add that all together, and we get 22. So the square root of 22 is the Frobenius norm, and 4.69. Typically you answer to 2 decimal places, but that would be in a question which is asked of you. Okay. Homework. So for the two-dimensional matrix, determine the norm. the spectral norm, the infinity, and the Frobenius norm. And question 2, do it with a three-dimensional matrix. If you get stuck, the answers are there. You can go to the Omni calculator to work it out. And maybe you might say, Dr. Everett, please do that one for me. Okay, that's all. God bless you. Stay safe. I will see you next week. Okay, bye.